All right, what are your answers here? 1 over 5 and negative 2 over 5. Do you guys see how easy it is? Okay, you should be able to look at this and say the horizontal asymptotes, okay, are when the limit of 1 minus 2 e to the x over 5 e to the x plus 5, when x, wait, to take HAs, you take the limit both ways. To find BAs, remove the holes, set the bottom to 0. If there are no holes to remove, you just set the bottom to 0. All right. So guys, if on your test you write just this, you get 1 point. Okay. Nice, right? And that's okay because you're losing 1 point in every other place anyway. So it just adds up. It all adds up, okay, to maybe 5 points. All right. Over here, you need to know what e to the x looks like. E to the x looks like this. Okay. When e to the x goes to negative infinity, or I'm sorry, when x goes to negative infinity, e to the x goes to infinity. When x goes to, wait, that's totally wrong. Sorry. Let me do proper notation. The limit as x goes to infinity. When x goes to infinity, e to the x goes to what? Infinity. Over here, when x goes to negative infinity, e to the x goes to what? Careful, it's not infinity. It's actually 0. It's the y value. So guys, when you have the limit going to negative infinity, what happens here is the e to the x's go to 0. So this becomes 1 minus 0 over 0 plus 5. And that's where you get the 1/5. Okay, really just pull it out of this picture. All right? When x goes to infinity, okay, what happens is this is super big and this is super big. And while I don't understand it, you guys might. Okay, what it is that if you have so much money that if someone gave you $1, you wouldn't take it. Okay, FYI, I take money in this class. Okay, but if you were like that, okay, if you had so much money that someone gave you $1, you'd be like, I don't care. Okay, then what that means is that this is negligible. Like the 1 and the 5 are negligible here. The 1 and the 5 are not negligible here because compared to 0, that's $1 is a lot of money. Okay, but compared to infinity, these are negligible. So this becomes the limit as x goes to positive infinity of negative 2x over 5ex, okay? And whenever you do numerical methods to do limits, you would plug in the same number here. So if you plug in 10,000 here and 10,000 here, do you see the e's cancel out? I mean, or even if you plugged in a gazillion here, if you plug in a gazillion here and a gazillion here, do you see the e's cancel out? Okay? And so this answer is always negative 2/5. All right? And again, you can just look at the problem. Eventually, you should be able to look at the problem and see that it's negative 2/5 and 1/5. Those are the horizontal asymptotes. Okay. Another thing I need to tell you, it doesn't have to be an E. Okay? Because E is really just what? It's just a number. What constant is it? 2.7? Is that right, guys? Okay, 2.7? Something like that, okay? But guys, it doesn't matter what E is. If this were 5, they would do a little bit different notation. It'd be times 5 to the EX. This would still be the same answer. Does that make sense? It doesn't even have to be 5. It could be pi. You could put a pi here. It would be the exact same answer. Is everybody good with that? All right, we've done this so many times. I hope on the next test you'll be okay with it. All right, two other problems I want to do with you guys. This problem here is on your quiz today, so you need to know how to do this for your quiz, okay? Here's the problem. G is twice differentiable, and guys, people confuse this on the test. When I say G is twice differentiable or F is twice differentiable, all it means is that G double prime exists. It doesn't mean do anything to it. As a matter of fact, most of the time you could just disregard that statement, okay? It just means it exists, okay? If it exists, then you have a G double prime. So it says G prime is greater than 0, guys, that means G prime is positive, and G double prime is greater than 0. That means G double prime is positive. And guys, I've told you this before, but you need to understand that you need to memorize, this needs to be memorized on the back of your hand. When G prime is positive, G is increasing. When G prime is negative, G is decreasing. If you move from one row to the other row, it's not an F problem, sorry, G will have a relative max. If you move from the bottom row to the top row, G will have a relative min, okay? You've got to be able to, when you get your test, you get it, I would just write that on your test, okay? That's going to help you with 90% of the problems, okay? Then you also know when G double prime is positive, what do you know about G prime? Increasing, and G is concave up. And if G double prime is negative, what do you know about G prime? It's decreasing and G is concave down. What happens when I move between these two rows? I have a POI. On what function though? On G. Okay, so the POIs are always back on the original function G. All right, so I've memorized these and I look at this and I say, you know what? What does it tell me? It tells me these prime things. I don't totally understand why, but let me look at what they give me. Given G value at 1, G value at 2, G value at 3, and they want me to find the G value at 4. Okay, well let me think about that. What they gave me is I've got this G function. At 1, they tell me the value is 3. At 2, the G value is 4. At 3, the G value is 8. And at 4, they're saying, what is it? Okay, you guys good so far? This is what I'm trying to figure out. Okay, then what I also know is that G prime is positive. Okay, well, if G prime is positive, what do I know about G? It's always increasing. You guys good with that? So if I look at these numbers, 3, 4, 8, what, of all these multiple choices, which one do I have to eliminate? Okay, because it wouldn't be increasing. Everybody good so far? Okay, G is always increasing. All right, next thing I need to know is how am I going to use this G double prime as positive? Well, when G double prime is positive, remember everything on the row is synonymous. So if G double prime is positive, G prime is definitely always increasing, and G is definitely always concave, wherever G double prime is positive. Okay? Well, let me think about this. The G concave up, I mean, I could draw this thing. Let's see, 1, 3, 2, 4, 3, 8. I mean, what I know, if this is my G graph, is that it's always increasing and it's always concave up. You guys good with that? At least between 1 and 4. So if that's true, I don't know that concave up will help me. Let me look at this G prime increasing. That's really just the what? Slope. The slope. Can you guys get slopes when you have a chart like this? Yes. Okay. What's the slope right here?
1.
You see it's 4 minus 3 divided by 2 minus 1? You guys good with that? So the slope is 1. What's the slope right here? 4 over 1. Okay, this slope needs to be what though? Greater than 4. How did I know that this slope needs to be greater than 4? Because the slope is increasing. Is everybody good with that? Okay, so which of these numbers will help me get the slope to be bigger than 4? Let me put in 12. If I put in 12 here, what's the slope going to be? 4. Okay, is that bigger than 4? No. Okay, try a bigger number. 15. Is that going to help me out? Yes. So if I put in 15, what's the slope? Is that 7? Okay, so there's your answer.
So, like that, since it was yours just to choose the biggest number.
Oh, what a nice conclusion. Okay.
Is that always the case?
For this problem, yes.
Okay, cool.
Yes, for these types of problems, yes. And then I want to do one more problem with you guys. This is a test question. I put a star on this. You will see it again, I promise. Okay. There's 5 points on this curve. This is a curve of, I should have said it, but this is a curve of y. So this is a picture of y, similar to f. Okay, picture of f. I know 2 things about the derivative of f and the derivative of f. The first derivative of f I know is negative, or the first derivative of y is negative. And I know the second derivative of y is negative. Okay, so what I know is that y prime is negative, and I know y double prime is negative. Okay, tell me guys, which point is this going to be true? The answer is going to be A, B, C, D, or E. Okay, so some of you guys, I'm not sure if you're even looking here, but the answer is going to be A, B, C, D, or E. At which point is both the first derivative negative and the second derivative is going to be negative? I'm looking at a picture of y. Okay, you could narrow it down. Let's do this. Remember, when y prime is positive, y is increasing, right? But when y prime is negative, what's y doing? Decreasing. So for sure, it's got to be on the decreasing part, right? Okay, but also, let me just clarify. What's y prime right here at D? 0. Okay, so it's going to be B or C. Everybody good with that? Let's go to the second derivatives test. The second derivatives test says when y double prime is positive, y prime is increasing, y is concave up. When y double prime is negative, oops, here's what I got here. When y double prime is negative, y prime is going to be what? Decreasing, or y is going to be what? concave down. Remember, they're exactly the same. This is a picture of y. Which one, B or C, is y concave down? B. So do you see that the answer is B?
Yeah.
Okay, so you're going to have to be able to answer questions about different points on a graph like this. All right, go ahead and pass up your warm-ups, guys, and let's look at your homework. I'd like to do, you guys okay with number 9 on the homework? Can I do it with you guys? Okay, look at number 9. Here we go, guys. Look at number 9. Pull out your homework. First and second derivative. Oh, no, it's the second derivative. Sorry, second derivative type. Pull out number 9. And Brent, you have a brand new worksheet, right?
Yeah.
Okay.
Can I show you my homework from Wednesday?
Yeah, I'll check homework while you guys are doing your quiz. All right. Guys, they're giving me a picture of F double prime. Okay? Guys, his name is F double prime. Please don't rename him, okay? Doesn't it upset you when I call you the wrong name? Okay, because like you might think that I'm racist or something, right? Okay, so you don't want to be called the wrong name. This guy is F double prime. Don't call him F. Don't call him F prime. Okay, here we go. The graph of F double prime is shown. State the x coordinates where there's a POI of F. Where's there a POI at F? Okay, F is in another room. You cannot see F. Okay. But what do you know about F? You know when F double prime is positive, what do you know about F? F prime is increasing and F is concave up. And when F double prime is negative, F prime is decreasing and F is concave down. When does the POI happen? You're trying to figure out the POI.
When they change.
There you go. When you change between this row and this row. And remember, everything on this row is synonymous. They're synonyms with each other. Everything on this row is synonymous. So if you tell me F is concave down, then you're also telling me that F prime is decreasing. Does that make sense? Everything is synonymous. All right. So guys, I have no idea what F prime is, and I certainly can't see in the other room what F looks like, but I certainly know exactly what F double prime looks like. Okay? So a POI happens. Okay, let me make sure you understand this. This is a POI on F. Okay, POI happens on F, so F is in another room. It happens when F double prime changes from what? Positive to negative or negative to positive. Where on this graph, this is F double prime. Does F double prime change from positive to negative or negative to positive? What point? X equals 1. Where else? 7. Does it happen here? No, because here F double prime is positive, and here F double prime is positive, right? So it's changing from positive to positive. That's not a POI. Okay, so this is your answer, 1 and 7. You see how easy that is? If you've memorized this, or if you have this on your paper, okay? So go ahead and start memorizing that. People also ask me about 10E. Do you guys need help with 10E, or do you feel good about it? 10E. Maybe 10D. 10D, I'm sorry, 10D. You need help with 10D? Okay, let's do 10D. 10D says, give me the values of x when h has a horizontal tangent line. Okay, guys? When h has a horizontal tangent line, what's the derivative at h? Okay, so I know that whatever that value x is, it's when h prime of x equals 0. All right. Well, what is h prime? H prime is when you take the derivative of the chain rule. So h prime of x is going to be f prime of g of x times g prime of x. Everybody good with that? Okay, that's what h prime is. This is what h prime is. Well, let me put them together. This is going to equal 0. Okay, so if this is equal to 0, if something times something equals a 0, what does that mean about one of these somethings? One of them is 0. It's got to be. That's multiplication. All right. So that means f prime of g of x is equal to 0, or g prime of x is equal to 0. One of those has to be true. All right. What is the x value when this happens? So go look at your curve. This is your g curve. When does it happen that your derivative is 0? 2. So x equals 2. That's one of your answers. When x is equal to 2, h prime is going to be 0. You guys good with that? Okay, I've got another one I have to deal with, though. Okay, I have to deal with this one. Oh, this one's stuck. Okay, I'm going to erase this if you're okay with that. Sorry. You already have one answer, x equals 2, so we got that. All right, over here, this looks really terrible. Let me rewrite that. This looks really terrible, but just call this some insight. Okay, What does the inside need to be for f prime to be 0? So look at your f graph. What does the inside need to be for your f prime to be 0? 4. Okay, some of you guys might have said 2, and I'm okay with that, but usually if there's a horizontal tangent line, it's real obvious. But if you said 2, I can see where you think there might be a horizontal tangent line. You can work that one too. But for sure, if this were 4, does that make sense? For sure, if the inside were 4, the derivative of f would be 0. You guys good with that? Well, now let's work this backward. If g of x is 4, what's x going to be? That means on your g graph, the y value is what? 4. So here's my 4. What's my x going to be? There's 2 numbers, really. You guys see them? What did you guys get? 4 or 1/4? I mean, just estimate. Okay, so those are all your answers. 4, 1/4, 2. If you thought this was a horizontal tangent line, you also might have thought, you also might have gotten 1 and 2 2/3. Okay, if you thought this one was a horizontal tangent line. Okay? All right, you guys good on that? All right, let's go to number 11. Students had questions about 11. Okay. Guys, it says, for what values of a and b does a function have a local max or a local min? Guys, what's happening to the derivative if I have a local max or a local min? What's happening at the derivative there? 0. So what that means, guys, if you take the derivative of this, okay, set it equal to 0. So take the derivative, and be careful, or just understand that when you take the derivative of a constant, a and b are constants, the derivative of ax squared is 2ax. You see that? You need to be able to do that. And the derivative of bx is just b, right? The derivative of 5x is just 5, right? The derivative of 3x is just 3, right? So it's b. So you set that equal to 0. And what you know is this happens at 2 points. It happens when x is -3, and it happens when x is -1, right? That's only 2 times, well, that you know for sure it happens, okay? So go ahead and do 2 equations with this. One equation, put in x equals -3, and set that equal to 0, right? The second equation, put x equals -1, and set that equal to 0. Isn't that true, right? Isn't the derivative equal to 0 when x is -3? And isn't the derivative equal to 0 when x equals -1? Then what's going to happen, guys, is you'll have 2 equations, 2 unknowns, and you'll just solve for a and b. Okay, 2 equations with a and b, and you just solve for a and b. Okay, that's how you do number 11. Okay, and the mother of all problems. Here we go. Number 12. Let's talk about what we know about this problem. Okay. When you're doing this one, okay, we already talked about part B. Part B said that this was an odd problem, okay? So whatever you get on the right side, okay, just flip it, and it'll be symmetrical that way. Just flip it and flip it, okay? The domain is -∞ to 0, 0 to infinity. So something, I mean, it's not an equal here at 0. Something's happening at 0. Actually, basically it's saying nothing's happening at 0, okay? And so probably vertical asymptote, but we don't know. Let's just hold off on that first. Right here, this says y goes to infinity when x goes to 0 from the right. So we already know that. That's good with that. Okay, we already know that. And actually, we probably already know this now. Okay, this is going to be a vertical asymptote. I mean, it's going to approach infinity right there. Okay? This says for x is greater than 0. Oh, wait, I skipped D, sorry. Look at D. D says the limit as x goes to infinity. Guys, that's a horizontal asymptote, right? The horizontal asymptote is 0 where? When x goes to infinity. So way out here, I know that the horizontal asymptote is 0. So what do I know that the picture looks like? I know that the y value is 0 way out here, way out in infinity land, okay? Way out there, okay? So you guys know one of those red things is true. I don't know which one. Everybody good so far? It's a function, so it's going to be one of those. All right, let's look at letter E. Letter E says on the right side of the graph, f of x is equal to 0 only at one point, and at that point it's going to be x equals 1. Okay, so what that means is my y is equal to 0, okay, only at one point. That's an x-intercept, right? When y equals 0, that's an x-intercept. When x equals 0, that's a y-intercept. Okay, that means only at x equals 1. So here I have an x-intercept, and that's my only x-intercept. Everybody good so far? That's my only x-intercept. Okay, and then, well, let me just go ahead and start drawing what I have. Okay, if I were to draw this, I would say, okay, I'm coming down here. It's going to hit this number here. Okay, once it hits this number, remember, there's only one x-intercept, so it can either bounce up, okay, but eventually it's going to have to bounce down to come here. You guys good with that? Okay. It could also go through this thing. Okay, if it went through, it also would need to eventually bounce up to come up here. Is everybody good with that? Those are my two options right now. Okay, let me add in more things. Here we go. Right here, letter F, it says on the right side of the graph, the derivative is 0 only at x equals 2. Okay, that's the only time when the derivative is 0. So it only happens once. Okay, only happens once. One time. Okay, the derivative is 0. Well, guys, slope of 0, superhero. What's happening there? Relative min, relative max, horizontal tangent line. Only one of those things is happening. At where? X equals 2. So let me call this my 2. I'm just going to space it out a little bit more. This is my 1. Okay, not to scale. All right. So at 2, what's going to happen? You're either going to have a relative min, a relative max, or a horizontal tangent line. You good with that?
Yeah.
Okay. If we were following this one, it would be a relative max and come down. That would be pretty nice, right?
Yeah.
If it were a horizontal tangent line, it would go like this, come over, and go up, right? Well, actually come over, up, and then it would come back down. So up, and then it would come back down. Everybody good with that? Okay. This is starting to look like Halloween. Okay. Over here, if I had a relative slope of 0 here at 2, this would go up, this would go up, and then eventually connect there, right? Or it could be a horizontal tangent line, which means it would come horizontal, it would come down. Oops, but it needs to come back up. So it would come down, and it would come back up. Okay, so it's one of these 4 lines. Okay, so now we need to figure out which one it is. Reread this one. It says the relative max, min, or horizontal tangent line. You can have a slope of 0 only how many times? 1. You can only have a relative max, min, or horizontal tangent line only once, and that has to happen at 2. Okay, so if I follow this line here, this top line here, how many times do I have slope of 0? 1. I don't know if this counted. 2, 3. Okay, more than 1. So it's not this line. All right, let's look at this one. If this were the relative max, how many horizontal tangent lines of 0 would I have here? 1. Do you see there's 1 here? 1, 2. Do you see that? And this rule says you can have a horizontal tangent only once, and that has to be only at x equals 2. It can't be at 1. You guys see that? So therefore, I eliminate this problem too. All right, let's look at this third line. On the third line, I'm going to come right down through the 1. Okay, do I have a horizontal tangent line there? Nope. Okay, at 2, I'm going to head back up. Do I have a horizontal tangent line there? Yep. And then I'm going to head over here. How many horizontal tangent lines do I have on that one? 1. So it might be this one. Let's look at the fourth line. When I come down, a horizontal tangent line here, and a horizontal tangent line here. You guys see that? So it can't be this one either, because that one gives me 2 horizontal tangent lines. All right, so what's my answer? This middle one right here. I was going to say this ugly one, but they're all ugly. So remember what we learned in here. Okay, even if you have ugly children, you keep them. So here we go. All right, you do something that looks like that. All right, the second derivative is equal to 0 only at x equals 3. Let me look at my final letter here. What happens when you have a second derivative equal to 0? What happens there? It's a point of inflection, okay? Your second derivative is equal to 0 only at x equals 3. And so let me just call this 3 here. And what's going to happen, this is my f graph. So what happens to f when you have a POI? F changes from what? Concave up to concave down, or concave down to concave up. So that's what's going to happen here, right here. And it makes sense, right? And it only happens once. So this is all concave up. The whole thing is concave up all the way until you get to 3. And at 3, you're going to flex. Does that make sense? It's going to turn to concave down. And it'll be concave down all the way to your horizontal asymptote to infinity. Okay, x to infinity. That was nice. Did you get that?
I did.
Okay, that's not the whole graph though. What do we have to do?
That one.
We have to flip it, okay? So all that means is this goes, you know, you fold it twice. This goes here. If you flip here at 0, it's still 0. If you flip 2, I don't know what that is. It's going to be up here. So let me draw this. It'll be something like,
Yeah, not bad.
does
Yeah.
that make sense? We're just making an odd function. Okay, so you're flipping it, flipping it. So if you fold your paper and you fold it again, it should like trace on itself. Okay, right there. All right, how are you guys feeling?
Great.
Okay, go for your quiz. I'll be walking around helping you guys. Please leave your homework out. I'll be checking that. Hopefully you were doing it while I was doing it with you.